Okay, in these next examples, we kind of want to go the opposite way. So instead of using Pythagorean theorem to find a missing side length, we want to use the converse of the Pythagorean theorem to prove if these three side lengths would make a right triangle or if it would not be a right triangle. So it is a right triangle if c squared is equal to a squared plus b squared. We don't know yet, so I just want to analyze these sides. Remember, c was always our hypotenuse. In this case, we don't have a triangle, but we know c is always going to be the longest side. That's what matters. So c is 7, so 7 squared. And I want to compare that to the sum of 5 squared plus 6 squared. So 7 squared is 49. I know that. Let's see, 5 squared is 25 plus 6 squared is 36. Whoopsies. Add those two together and you get 61. Well, 61 pretty clearly is not equal to 49, so that is not a right triangle. Simple as that. Not right. Okay, let's do it again. Here are these three side lengths. Just remember 25 is your hypotenuse, so I'm going to compare 25 squared with the sum of the two smaller sides squared. So 15 squared plus 20 squared. In this case, 25 squared is 625, and 15 squared is 225, and 20 squared is 400. Add those two together, and what do you know? 625 is equal to 625. Because those two are equal, great, that is a right triangle. Cool. That's a Pythagorean triple, actually. 3, 4, 5 times 5. Last one. Let's see if I can squeeze this in. Again, longest side is 18, so that's C. So it's going to be 18 squared. And I want to compare that to the sum of 10 squared plus 14 squared. I think I need thinner markers. 18 squared is 324. 10 squared is 100. And 14 squared is 196. Add those two together and you're going to see 324 is not equal to 296. Therefore, it's not a right triangle. Okay? So this is using, again, the Pythagorean theorem converse to prove if a triangle is right.